Red Hat, and I'm going to talk about Kubernetes on OpenStack, why you want to do that. Okay, so there are two parts to this. There is infrastructure as a service, which is OpenStack, and then there are Kubernetes orchestrated by containers. So what does OpenStack do? It exposes the resources, and those resources are storage, compute, and networking. Okay, so that exposes, and the bare metal service. So that exposes that to the, it provides a layer on which Kubernetes can then run. And containers, therefore, consume the resources. Okay, so they will access the storage, access the networking, access the hypervisor to run on top, and the compute. So why do you want to do it this way? Why do you want to, what is the benefit of having that OpenStack layer there? So OpenStack is doing that automation and exposition of those resources. So as I said, the compute, storage, and networking is exposed and then consumed by the Kubernetes on top. And what is the advantage of having OpenStack there? So it's automation. Automation is everything that's required in the data center today. Okay, that means by OpenStack can automatically expose the compute, it can expose the storage, the networking, and we'll see in a second there's something called Ironic, which is the bare metal service, and that can expose the actual servers. So if you want to run Kubernetes on bare metal, OpenStack can do that for you, or if you want to run Kubernetes on OpenStack instances, it can do that for you as well. So it scales very well. It will scale up, scale down as the cloud grows or expands. Then Kubernetes comes along and consumes the resources, okay? And it uses those API calls as we saw earlier. The container sits on top, and it just simply consumes whatever OpenStack has provided for it. There's for those who've seen Kubernetes, there's the dashboard, there's the API layer, the CLI, whichever way you want to consume it, it's there for you and available. So when you put it together, you get a sandwich. You get OpenStack at the bottom, infrastructure as a service, you get Kubernetes on top, and then your application, which can be a SaaS application or as you wish. Okay? And the management is simplified because OpenStack is doing that automation for you, and Kubernetes can then consume. Are there any questions at this point? Because I'll probably go a little quicker than they expected. So if you want to interrupt with questions along the way, let me know. Yes?
What level of adoption do you see for Kubernetes and OpenStack?
What?
What level of adoption do you see?
So what level of adoption? So the use cases here are typically in a hosted environment or in a private cloud where you want to do the automation. You want to automatically make available bare metal servers or a hypervisor plane controlled by OpenStack for Kubernetes to consume. It's good for like running a big data application on top, which you need to scale out as you're running the analysis on the data. Then you need to scale out as you do that Kafka job, or pick your, I don't want to be prescriptive here, pick your big data application, Cloudera or Hortonworks, it's now one company, whatever, whichever one you want to do, you run on that and you do your data job, it grows out, and then when you're back, you can free up and make that rack of servers available to another application or another use. Another question? Okay. So, technical advantages, I won't read the slide necessarily, I'll let you consume it for a bit. As again, automation is key here. It's consistent, so every time you run that OpenStack, you're getting really the same level of service, whether you're making available one rack of servers, 5 racks of servers, it's consistently will do the same automated way of making either the hypervisor with instances or the bare metal available to you. And for networking, there's Open vSwitch as we have in native in OpenStack, or a number of plugins that I've listed here, or others. So there's some business value that is very much the same. I think that was a duplicate. Oops. So the OpenStack bare metal service. Okay, as I said, OpenStack is known for providing that cloud-like layer of virtual machines, although call them instances, virtualized compute storage and networking. But it has something called Ironic, which is a bare metal service. And what does that do? It takes a rack of servers with nothing on them and can automatically layer something on top, throw on an operating system, throw on a cloud, or make them available as sort of one uniform set of compute storage and networking, not isolated disks located in all the servers. So that's called Ironic. And it integrates with other OpenStack services, Neutron for networking, Nova for compute, Cinder for storage, to give you bare metal as a service, very, very much similar to what you're getting in the public cloud. So if you go into a public cloud and you say, give me 12 instances of pick your public cloud provider and give me some S3 or some EBS type of storage and attach it. So bare metal as a service is doing the same, except in your colo or in your data center. So it should be highly available. Okay, so if you want to, you need a minimum of 3 compute nodes to make OpenStack highly available. There is something called pacemaker, not the pacemaker in your chest, but there's a pacemaker agent that coordinates the cluster of the servers. There's something called HA proxy, which will do load balancing, and then Ceph is object-based storage, and we'll see there's going to be another Ceph slide coming up. We want to do Kubernetes high availability, so then the OpenStack nodes are provided at the bottom, and you get Ceph OSDs are grouped on the zones in a per rack available basis. And they're all members of the same OpenStack tenant. So an OpenStack tenant is like if you think of a tenant in an apartment building or in an office building, okay, they share that infrastructure and they are all responsible for their own interior, and they're isolated for their own interior use of the apartment or the office, but they share the parking garage, they share the elevator, they share the grounds. You get the idea of what that shared environment is within. I'll get to your question. So that is what we call multi-tenancy and how OpenStack creates a tenant. And the affinity rule will ensure that certain nodes are restricted to stay, if you need, to remain on certain hosts. There may be use cases for that. Was there a question in front?
Yes, your bare metal as a service. You don't get you don't have luxury of virtualization.
Correct. It's there to manipulate a rack of blank servers. It's just, in the old days, you had to walk up to each one and turn on the power.
Right now, you just give it to you.
You give it to the bare metal service, you give it to the top of rack switch, and it powers them on, and it reads all the disks in them, and then you can tell it, give me 1 terabyte, give me 3 sets of 333 gigabytes, or however you want to partition that whole rack of disks.
Is it guaranteed that it is from the same rack?
Yes, because you have top of rack switch that's talking to that rack.
You will locate one on this rack and another one on this.
You can. It can span across racks for sure. Okay, onto storage. We need, for HA, we need a minimum of 3 Ceph monitors and 3 OSD nodes. Okay, and we recommend dedicated servers. Okay, now we come to Kubernetes tenant networking, and there are 2 networks. One is a public network, which is kind of obvious. The other one is the deployment network, which is internal. That is the green one. So all instances live on the deployment network, and they go out on the public. You'll see something there called Courier, K-U-R-Y-R, and we're going to talk about that next. So what is this Courier? Okay, so you have OpenStack, which does networking, and you have Kubernetes, which does networking. So now you can have some double encapsulation problem or some two networks operating at the same time. How are you going to get around this? So Courier everything is open source. It's an open source project. Okay, you want that you have that problem of duplicate complexity of two SDNs on top of one on top of the other. So it's a CNI, Container Native Interface plugin, container networking interface, to integrate Neutron, which is OpenStack networking, and Kubernetes networking. So the Courier controller watches for events and OpenStack platform resources for them, and allows them to exist on the same network. So it eliminates that overlay problem. And there's also a similar idea for storage. I didn't put it into the slide, but you may have a double storage issue as well. So now we have compute. So what is heat? Okay, heat is the way in which OpenStack creates compute nodes. So compute is a virtual server, and heat will orchestrate and go out to all those CPUs in the rack that we talked about and the disks, and create out of that virtual machines, instances on which, if you want, you can run OpenStack or other applications. And it is that interface for if you want Kubernetes to sit on top. Again, it's all about automation. So heat goes out to Nova, which is the compute service of OpenStack, Ironic, which is the bare metal, to go down to the application node or onto the virtual node, and provisions that all together just to create that layer of availability. So finally, we'll have an architecture example. So OpenShift on OpenStack. So OpenShift is Red Hat's distribution of Kubernetes, along with other associated services on top with it. But you see here, OpenStack again is doing that shared layer of compute, networking, and storage on standard x86 hardware. KVM is the hypervisor. Ironic is the bare metal service. So there, OpenStack is either provisioning as a hypervisor for shared virtualization or directly on the server for bare metal. Some people say, well, why do you need the bare metal? What is the purpose of having Ironic? There are some applications that are maybe high performance applications or GPU type, where you want direct access to the physical NIC, the CPU, and you don't want the perceived slowness of that hypervisor layer in between. For those kinds of applications, you talk directly to the hardware, and Ironic will provide that standard hardware directly to you, if that is your application use case. If your application doesn't need that and virtualization is sufficient, then you run it on KVM. OpenStack behind the scenes is making all of that available to you, either a virtualization layer or directly on the server. So bare metal means it's directly on the hardware, only an operating system, no virtualization layer above that. So because you have KVM as a virtualization layer, therefore you have virtual machines that are sitting on that virtualization or OpenStack instances. And the container can sit on either one of those. So the Kubernetes containers can be on the instances or on the bare metal. And if we go into a deeper dive, it looks very similar, almost exactly as to what we saw earlier. Neutron networking is done by Octavia, which is the networking service, or Courier, which I said, remember, is that eliminating that double encapsulation of Kubernetes and OpenStack networking together. Storage, you can have either Cinder or Swift, object or block. Ironic is the bare metal, or KVM is the virtualization. Yeah, down there. Yeah. So that was it pretty much. It's applications, as I said, in your data center or in a colo facility. You can run a public cloud on it. There is several OpenStack public clouds out there. Deutsche Telekom is one large one. At least there are several in Asia that that are not running necessarily the big three that we have here, which I won't even mention by name. But OpenStack certainly runs a very big public cloud by itself, and those public clouds can have Kubernetes containers orchestrated on top of them. And Red Hat OpenShift is a Kubernetes distro, Red Hat OpenStack platform, Red Hat OpenStack, Ceph Storage can provide this to you. There were questions in the middle. If there are any more now, I'm happy to take.